In this video, we'll review a third technique of integration that we've discussed in this class, and that's the method of use substitution. I've restated the method somewhat abstractly in the formula below. What you're looking for is some function f of a variable u, where u depends on x as well. If you're lucky enough to see that, and its derivative, so the derivative of u is a factor of your expression, and you're integrating with respect to x, it's almost like the dx's cancel symbolically, and you're asked just to integrate f of u du. This will only involve the variable u, and hopefully this is a simpler integral that you can attack using some previously discussed method. Let's look at an example. I want to integrate tangent of 2x dx. What you might start with is writing this expression in terms of sines or cosines. So it turns out that the tangent, of course, is sine over cosine, so it's sine of 2x over cosine of 2x. Does this look attractive for substitution? And the answer is yes. You have sines and cosines, which are essentially each other's derivative with the right adjustment, plus or minus signs. So we should be able to take one of these to be u. Remember, you want the derivative du dx to be a factor of the integrand, and here sine is a factor, but cosine is in the denominator, so 1 over cosine is a factor of it, and that means the right choice of u will be the cosine function. We're going to take u to be cosine of 2x. Its derivative is minus sine. I put the 2x in, and then the chain rule says take the derivative of 2x to give me a factor of 2. I've written this as a differential, so du here, I bring the dx over, and I have minus 2 sine of 2x dx. I don't see any minus 2 in my original integrand, so I'm going to divide both sides by minus 2, and I'll have minus 1/2 du is equal to sine of 2x dx. We're now ready to do our substitution. It's 1 over cosine 2x, so that's 1 over u. And then my dx is replaced, or I'm sorry, my sine of 2x dx is replaced with minus 1/2 du. And we now have a new integral involving only u, and hopefully this is a form that we recognize, and in fact this is the derivative of the natural log function. So this is minus 1/2 natural log of u plus c. We include the absolute values to be as general as possible. We want an antiderivative that will work when u is negative as well. And then finally we back substitute u is equal to cosine of 2x. And we're effectively done with the problem. This is a function of x whose derivative is tangent of 2x. While we're here, we may as well review some of the properties of logarithms. If I have a multiple of a logarithm, so this multiple of minus 1/2, we can rewrite that as the log of the power of that. So in some sense, you bring that minus 1/2 up as an exponent. So I'm going to bring the minus 1/2 up as the exponent here, and of course a negative 1/2 power really just means 1 over the square root. So I'm taking 1 over the square root of the absolute value of cosine. Well, the reciprocal of cosine is secant, so finally we might write this as, instead of 1 over cosine, we might just write this as secant of 2x without the fraction in there now. So we're talking about the log of the square root of the absolute value of the secant of 2x. If you differentiate that function, you will get tangent of 2x.